喂，听到吗
哦，是吗？我没有听到你说话。
Hello，Hello，OK，那我继续啊。OK，那 proposal 的 submit 的 deadline 的话会是6月28号。那 Hackathon 的submit 了过后，我们会纸本的检查，然后会筛选出一定的队伍，那最后接下来进入一个是 preliminary 的 round，会在7月19。那过后呢，我们会筛选出12队的队伍进入 final report 的 preparation，时间是7月22号到9月18号。最后的 Hackathon 的 Grand Final 的话会在9月19号，是 physical 的 event，场地会在芙蓉中华中学。那在此之前的话，这些重要资料的话，稍后都会寄到各位的群组。那也再次感谢大家拨空参与今天的 Hackathon。我邀请一下我们的国立台湾大学马来西亚校友会的会长，帮我们说2句话。
好，谢谢世谋。哎，大家早上好。南门大学的老师，各位同学，感谢你们参加今天的黑客松比赛。那黑客松比赛呢，都一般上是给大学生和那个职场上寻求解决方案跟发掘人才的那个手段了。那这一次呢，把它移到中学生哦，让你们提前对日后的做研究或工作上有提前做一个练习的准备。那今天的这个工作坊主要让同学更加理解和熟悉对新领域和新知识的掌握和表达了。那也非常感谢南门大学的老师哈、特地在比赛前安排3场的相关课程，那帮助同学如何准备报告和表达的技巧。那希望同学好好把握。那比赛有输赢啦。那参加这个活动呢，是让大家提早获得大学老师的授课，那学到做研究的基本方法，将会是同学最大的收获了。那祝同学们一切顺利，谢谢。
谢谢我们的会长。那我们接下来由我们的Dr. Teo 跟 Dr. So 开始今天的 workshop。我应该设成大家是 co-host 可以 share 的。等一下啊，可能是 Dr. So 那边有跳出去。诶，Dr. So，你有看到 Dr. So？ Dr. Teo 是你先开始吗
哦，是我都说开始先。
？Dr. So，因为人不见了。
刚才我看他在里面。
对对对，我刚才设成他是
我联络一
co-host。
下哈。
没关系，OK，我看一下，也没有看到人呢。好，好，那我们等他的同时，我 text 他一下。诶，Dr. 丢你有 Dr. So 的电话吗？我没有我发现他没有在群组。
有，我在联络着他。
OK，好，OK，那我先存一下时间。
好。不好意思，等一下子。
好，没事没事。OK，大 FAQ 的部分呢，如果他进来跟我说一下，我再称他是 co-host。大家会
嗯
提一个问题，就是 NSSBC 跟 Hackathon 到底有本质的差异性？基本上呢，NSSBC 是跟全世界一样的，全世界，嗯，前4年是一样的，也就是说，它是 programming contest，也就是用大家学习一个 programming 的 skill。然后来解决一些封闭式有答案的问题。所以同学需要经过 qualification，然后 group a team，找3位同学或者朋友一起组成一队。那接下来的话，参与我们的预赛。那最后通过过后，我们会晋级决赛。决赛会有 60队的队伍，决赛地点我看一下，哦有看到了，我的收进来了，OK，好，那稍后的话，今天的分享结束后，我会再说明一下关于这个 FAQ。OK，Dr. So，你可以分享你的 slide。哦，今天的分享会是用英文来分享。叮叮叮，可以吗？有需要协助吗？叮叮叮，呃不是的黑客松大家有疑问的话，可以在群组询问哦，可以在那个 chat group 那边。会的，会在官网回放。呃，嗯，
是么？你可以你可以先回答他们的问题先。
哦，好的好的
他的那个有
，OK，
点问题
好，没事
没
没事
不好意
，OK，
思。
那我先回答大家问题。黑客松不是黑客的工作，OK，黑客松只是一个 Hackathon 的比赛。不是的，不是每一个参加 NSHPC 一定要参加 Hackathon。Hackathon 是，如果你对于这个，我看一下，我再回到刚才的 slide。如果好了，跟我讲一下哦。OK。那 Hackathon 呢，是你已经学会了一些基本的 programming 的 skill，然后你想要试着解决一些现实生活的难题，那你可以建议你参加，不一定需要参加，但是可以参加。那我们今天的主题呢是用 AI 跟一些embedded system 来解决智慧农业的问题。啊，那再来的话是，你可以同时参加，你也可以选择一项参加，也就是说，你可以参加 NSFCC 而已，或者你可以参加 Hackathon 而已，或者两个都可以参加。我一面回答，OK，可以，不是的，等一下啊，OK，来，原因是这样子的，因为刚才有冲英卫同学问说，诶，那个 deadline 是为什么是12号？为什么会改成28号？是这样子，如果你是参加 hackathon 的同学，你的 proposal 需要在6月28号缴交，原因是因为我们希望预留多一些时间，让同学可以跟 U 大的团队可以有一个 final report 的 preparation 的时间，所以这个是给 hackathon 而已。那如果你是参加 NSSPC 的 programming contest 的话，你的缴交时间会是在7月12号。嗯，那可以，等一下大家可以一面写哦。如果等一下开始了过后，我用文字来回答大家。嗯，大家可以继续把你的疑问写在那个 meeting chat 里面。OK，我继续讲，大家有疑问可以写。那再来的话是如何注册两个竞赛？如果你觉得听起来蛮好玩的，两个都想参加的话，很简单，就是你已经报名了，去这个地方那边登记完过后，去到 personal 的 information，你只要在 contest 的 team name 填你的 team 的名字无论你现在已经找到一位同学自己而已，还是已经有一组的 team，那你就可以在 contest 的 team name 那边写上你的队名啊。如果你今年在7月12号过后，真的你已经通过了资格考，但是找不到队友，我们主办当局会协助你，找一些还没有找到队友的朋友一起 group 成一个 team。那第二个是 Hackathon 的 team name，我们会建议你在 Hackathon 的时候，在6月28号前就找好 team 了。Hackathon 要用什么写代码？Hackathon 不限制， Hackathon 的是最终你需要交一个 proposal 啊，没关系，我先不回答那个 meeting chat 的问题，meeting chat 等下我再统一回答。OK，点啦。那再来的话是，如果你怎么样确定说你的 profile 的 information 是已经完全注册完了呢？你一样登录到你的 account detail 的 setting 网站在这里，那如果你看到你登录过后呢，写着福利 update 的，这个就是你的所有详细资料都已经完全填完了，那如果你已经通过通过资格考过后，我们就会正式发一个通过资格考的证书给你，参与证书的，那如果你显示黄色的，就是 missing info 的话，你可以去底下看看说你什么资料是少填的，最重要需要填你的 IC full name，然后 email，你的性别，你的学校的班级，你是 Form 1到 Form 6。然后再来的话是你的 IC number 或者 passport number，如果你是外国人的话，你就填 passport number；如果你是马来西亚人，就填 IC number。然后你的生日日期，然后你的学校的英文名字，大家请确定哦，自己的学校英文名字不要填成自己的名字。OK，那大家先在 meeting chat 里面回答写你的问题，我会统一回答。那 addition 的 important information 呢，包括了这些资讯，OK，那再来的话是，如果你还有一些其他的 chat 的 document 的 information 不确定的话，就直接去我们的官网那边会有写怎么样 flow 是怎么样的。那再来的话是一些重要的 document，还有一些是大家常问的一些 FAQ 的问题。OK，没有了。需要寄 slide 给我吗？我这里帮忙播，如果需要的话。诶，Dr. 说又不见了。哦，
我以为他已经进了，应该是。
等一下啊，
不进了，你 try 把录
我要 set 成
口
他是口号声
啊。
如果没有办法讲话，要跟我讲，因为我 set 成大家是进来是不能讲话的。
好的，都说可以了吗？
OK，
Hello, so
嗨，你好，
sorry.
是 OK，是 OK。
早上好。哎呀，
嗯
不好意思，这边有点小插曲。我刚才我的电脑没有插到电，所以不够电，所以它 restart。
，OK，OK，
Sorry. 啊，好，我现在可以了。
对
那个网应该是蛮stable right now. Yeah.
，OK，Yeah，好，You can share the slide。
Okay, sure. Give me a sec. I'm going to share. Okay. Oh, can you see?
Yeah，
Yeah, maybe wait. I'll just introduce myself a little. And where is my camera? Okay. Okay. Good morning, everyone. I'm so sorry for the delay. So without further ado, let me just introduce myself. I'm Saul. I will be sharing some of the basic programming, all right, using microbit. So basically, there are for a robot, all right. So I'm using a robot to explain what we are going to achieve today. So a robot basically composed of sensors and actuators. Now, before you can control the sensors and actuators as shown in this diagram, you must have a program, all right, to perform a sequence of actions. It's like you are instructing the robot what to do. All right, so this part will be conducted by me in the 1.5 hours. All right, the basic or the fundamentals of programming. And today we will be covering 6 different activities, okay, which actually consists of computational thinking. All right, what do you mean by algorithms? And then we will look at the basic concept of computer systems, which we have input and output. We don't forget about the sensors as well. So sensors is basically is the input, all right, of a robot. I'm taking a robot in for an example. It can be other things as well. It can be machine, all right. But all these is basically act like a robot, which consists of sensors, okay. Actuators is something that once they get the feedback, once they have the input, they will act on it, all right. They will respond. So this is the sensors part. Now the sensors part will be conducted by Dr. Teo. All right, he's the expert in this. So what I will be covering today would be the basic of computer algorithms, the computer systems, and the programming, which is the main part. But it's going to be a very simple and fun activities, I hope. All right. Now the programming part will have we will look at variables, iteration, looping, selection, and also randomization. Okay, just some basic concept that I'm going to share with you. So again, you can just call me Saw, SAW, or 你可以叫我舒老师也没问题。好。Okay, so I'm actually a lecturer in Utah, same as Dr. Teo, who he will explain later. And then, so sensors and actuators will be shared by Dr. Teo later, okay, for the details. Now, I have another slide. So basically, give me a second. So I'm going to off my video. So this is me, okay. I'm going to off my video so that it's not going to congest my network connection. All right, later. Thank you. Okay. Let me share. Later, I'll share the slides with you all. Okay. I think I will pass to Mr. Yo. Right, Mr. Yo will help me. Okay. Maybe I'll share the whole. The desktop. Yeah, I think I can share the whole desktop. Okay, so let's begin. Now, Microsoft actually has come up with a microcontroller. Oh, before that, maybe I'll show you, let me on my video again. So now it's not necessary to buy, but if let's say you want to continue with this program, okay, so this is how it looks like, microbit. It's a very small chip. It's cute, and it comes with a box. If you can buy in Shopee, costs about 80 plus, less than 100 ringgit. Okay, so you will get a box of all the manuals with all the batteries. Okay, manuals and batteries. So this is just to show you how it looks like. It's a very small chip. Okay, amazing. You can do amazing things, all right, using this chip. All right. Okay. But we are going to use a simulator. Okay, so don't worry if you don't have that today. Okay, let me off again. All right. So I have 6 lessons. So these slides are actually shared by this Microsoft. All right. So it's free to use. I will share it with you all later. All right. But if you have any questions, please ask. Okay. Don't worry. It's just a very simple lessons about programming using microbit. All right. Make code. So today for lesson 1, we are going to make a name batch. Okay. A name batch. Now, again, I think everyone know what is a computer, right? Mr. Yo, you know what is a computer? Just kidding. Okay, a computer. So computers are not just laptops and desktops. All right, so you can think about what computer can do. Okay, where do we find them? Do you think a phone is a computer? Oops, sorry. Okay, do you think a phone is a computer? Or how about a game console? And what else do you think has a computer inside? So basically, I think everyone here know what is a computer, the laptop that we're using, maybe the desktop that you're using in the lab, at school, and so on. But basically, it's not limited to laptop, or it's not limited to computer only, okay? They are all everywhere, okay? They are all around us, which includes your phone, which is very important right now, okay, for a phone. Without phone, you can't do anything, I think, okay? And then you have your game consoles. If you know Switch, Nintendo, okay, all those are also considered a computer. Okay, now even cars right now, nowadays, especially the EV, all right, they are also consist of computer in it to control, right? And your smart TV, okay, so it's everywhere. Yeah, it's not limited to just desktop or laptop. So again, so what is a microbit? So the chip that I show you just now, all right, it's a very tiny computer. Okay, microbit is just a very tiny computer. You can tell it what to do by writing instructions. Okay, so at home, your mom, okay, must have asked you to clean. I'm so sorry. Wait, let me just off my. It's my aunt. Okay, give me a second. I think I need to off my. Okay, I hope I have off it. Okay. So microbit is just a tiny computer, and you tell it what to do by writing instruction. So it's like your mom telling you, please clean your room. Okay, please bring the rubbish out, and so on. And even at school, your teachers will ask you to do homework at home. Okay, please submit by when, and so on and so forth. So the same thing goes to computer. Okay, you have to write, you have to give them instructions, but it's not in a word form, but it's in a coding format. All right, coding format. Now, the code. So we speak either Chinese or English. Okay, at home. So, in order to communicate with this tiny little computer, we call them microbit. Okay, we call that as an algorithm. Okay, it's kind of language. All right, it's a sequence of instructions. So algorithm is actually plays a very important role when you are writing a program. All right, so just remember algorithm is a sequence of instructions, and the microbit can show words. So as you can see from this diagram, okay, you can actually, this group of dotted rectangular panels, they are actually LED, all right, LED, a very small LED, where you can actually use, it's actually composed of the light emitting diodes, okay, and then you can show some lights, okay. So information coming out from this microbit, we call them as an output, all right, input and output. So you can play around later. I'll show you how you do it. Now, and you can unplug your microbit. You can attach it with a battery pad, and the code will still work. Now, I also will demo how you can actually use to actually send your code that you have written in this make code, and then to run it on the chips itself. But first, we will run it in a simulator. So let me just show you a short video. Okay, please let me know if you can't hear the sound.
It's really simple to get started with the BBC microbit. You just need a microbit, a micro USB cable, and a computer. The microbit is a piece of hardware, a tiny pocket-sized computer. To make it work, you have to tell it what to do by writing a computer program. Programs are called software. The micro USB cable is used to transfer the program onto the microbit. Let's have a look at it. On one side of the microbit, you will see 25 LEDs arranged as a square to make a simple display. There are also two input buttons, button A and button B. On the other side, you will see a reset button and a small socket to plug in a battery pack. We explore the processor and other features in further videos in this series. The microbit can only do what you tell it to do. So the first thing you need to do is write a program. You can use different programming languages to do this. For example, MakeCode, which works as a block and text editor, or the Python text-based editor. For beginners, MakeCode is a good place to start. We've selected some simple projects to help you. Choose one to get started. The latest version of the microbit has some exciting new features. The microphone adds a sound sensor. And the special LED on the front of the microbit lights up to show you when this new sound input is measuring sound levels. The speaker lets you add sound as an instant audio output to your projects. On the front of the new microbit, its logo is now gold. This new capacitive touch sensor is an input that helps you interact with your microbit in even more exciting ways. And now you can turn the new microbit off by holding your finger down on the reset button on the back, and you can wake it up by pressing it again.
Okay, so the last part is that they have this updated version of this microbit. So if you want to purchase, maybe you can try the latest version, because I'm using
From phones and tablets.
Okay, so this lesson, okay, what is the objective? Is that you can explain after this lesson, you can explain that microbit is a tiny computer. You can also explain that computer needs to be given a set of instructions or an algorithm encoding, and then you can actually use the microbit, all right, to make a name badge by utilizing the LED display output. Okay. Now I'm going to show you again another video about the thing that we are going to do.
Making a name badge is a great first project with your BBC microbit. You need to give your microbit instructions to tell it what to do. By making a name badge, you'll find out just how easy this is. Sets of step-by-step instructions are also called algorithms. We need to create our algorithms in a way that a computer, like a microbit, can understand. We do this by writing instructions in code in the MakeCode editor. Instructions written in code are called programs. You'll discover how to test code and modify it to make your own programs. Then transfer your program to your microbit to see your name on the microbit's LED display output. Unplug the microbit, attach a battery pack, and you can take your name badge anywhere. The next video shows you how to code your own microbit name badge.
Okay, so let's begin. Now, before we begin, I'm going to introduce you the microbit, all right, the MakeCode editor. So it's your first lesson with the microbit. So you need to know what parts that you are dealing with. Okay, so you can open up your browser. So and you type MakeCode like this. Let's see. Okay, just type Microsoft.org, and it comes to this page. Okay, you can sign in with your own this is my profile. I'm signing in using my Google account. If not, then you can actually sign up with a new account. Okay, so it will look like this. And there are many samples that you can play around. All right, and then, okay, now you can also click on new project. That's what we are going to do. But before that, let me show you. Okay, if I click on the new project, so I'm going to name as name batch. I'll give you some time later. Just let me show you. So once you have entered, okay, it comes to this page. It's okay, I do not need a tour. Okay, so you will see this is your simulator. Now, simulator is something that to show the output of your program that you have arranged or designed. All right, so you don't need a physical microbit. Okay, it's kind of, we call this as a simulator. So from here, you will see a toolbox. Okay, toolbox will be here in the middle part. All right, it's where they consist of all the information, all the things that you can use the programming. All right, to find the code blocks. That's the first part. We call them as a toolbox. And then this area we call this area as a workspace. So workspace is where you do your job. You do your code, you design your algorithm. All right, workspace. Followed by the simulator. Okay, as I mentioned, is to test your code, the output. And then you can download. Now, why you need to download? Because you want to transfer, okay, the written code to your physical microchip. Okay, but yeah, maybe I'm just going to show you once, and then later we will just focus on the simulator. Okay. So let's examine the code. Okay, now forever. Okay, so when you start the project, okay, by default, all right, by default they will have these two blocks, on start and forever. All right, now what forever does is a loop. So what do you mean by a loop? Looping is like it will keep on repeating. Okay, it will keep the code running without stop, without pause or rest. Okay, we call that forever in this block. And show string, okay, this is one example. Show string is to scroll the string of letters that make up your name across the LED display output. Okay, we can try that. We will try this exercise. Now the code then goes back to the top of the loop and runs again. So this is how it looks like. So it will start to execute. So once you have this block, okay, so it will start from here, do this instruction. So what is this instruction has to perform? Is to show a string, okay, on the LED. And then once they finish, okay, the code will go back to the front, and it keeps repeating, looping, okay, goes back again and again. So let's begin. Let's try it out. So this is another video to demo. So I'm going to show you. So go back to your make code editor. We call this as an editor where you design your algorithm. And then you can go to the basic. Okay, click on the basic and you will see a lot of different code blocks that you can find. Show number, show LED, show icon, show string, and so on. And this is the input. All right, we will see that later. Music, you can do music here. You can do, you can also instruct which LED to light, okay? Radio is actually for Bluetooth input. And then this is the looping, okay, to repeat an instruction. Okay, and then we have variables and mathematics. So a very simple example here, I'm going to go for show string, and then you just plug it into that block. Okay, and then you can just write your name, just like that. And yeah, automatically, they will show you the output in the simulator. Okay, just like that. Pretty simple, right? You can try. Any questions? I think everyone is okay with it, right? All right. Now, the next thing I'm going to show you. Okay, now you can download to see the effect. Do you want allow? Okay, allow. So they will download as a .hex extension file. All right. So it looks like it's something like this. It's a HEX. Where is my HEX? Oh. Download again. Or download it. Okay. Any questions for this one so far? Should be fine, right? Okay, very easy. Okay, now you can also code an animation. Okay, the animation, this is the step-by-step online tutorial you can also follow. I'll share this slide with you all. So this is just a warm-up of this first lesson. You will turn on your microbit. All right, does it work? So download, could it be other services? Okay, now this is the exercise that you might want to try out, okay, to show the icon and show the string. I'll give you some time, okay, maybe just 5 minutes, very simple. You can just do whatever you want. Now the show icon here is actually is in the basic toolbox, okay, and show icon. Okay, drag it here. There are different kind of patterns, okay, you can see. All right, please try it out. Just give you 5 minutes maybe. Then maybe you can, then we will continue to the second lessons. Meanwhile, let me check my, microbit. So this is the file that I have downloaded just now, HEX. Okay, microbit, this is my project name. All right, and .hex. All right, .hex. So now, what I did just now is that I have Again, maybe I'll on my video. So I have plugged in, right? Actually, so I have plugged in with the cable, which is provided when you purchase this microbit, and just plug into your laptop or computer, and they will have they will show, and then you just drag. Yeah, so this is my device. Okay, now the file just now be here. So this file you can just drag and drop it inside. Just drag and drop. Okay, once you've done that, now you will see my chip, okay, can display my name. So it's my name badge right now. Simple, right? Easy. Okay, so this is how you download and then, yeah, to deploy to your device. Okay, now let's proceed with another lessons. If you have any questions, please ask. If not, then I'll just continue. Okay, let me check my screen. No, looking. Okay. So let's continue with the second one. Okay, now this one is again lesson 2. Okay, to program a beating heart. Okay, again, it's a tiny computer, what we have learned in the lesson 1, and you tell it what to do by creating code, and then you can send to the microbit. And again, the code is an algorithm, it's a sequence of instructions, and you will have LED display, which uses as an output to send out information. Okay, and the forever loop kept the code running. Okay, so this time you can try a beating. Wait, let me check.
You can create all sorts of animated images on the LED display of your BBC microbit. We're going to start with a beating heart, and we'll use 2 of the built-in pictures, the large and small heart. By showing the large heart, pausing, then showing the small heart and repeating the sequence, we can create the illusion of a beating heart. So let's open the MakeCode editor and write our code.
Okay, so this is the code that you can try it out, okay, to show the icon, and it will pause. Now the pause here, again, the forever block is a loop which keeps the sequence going. All right, it's an infinite loop. All right, and then show icon and pause blocks make up the sequence. All right, changing the pause time makes the animation faster or slower. But before that, animation is actually a sequence of still images, okay, shown one after another, all right, to look like a movement. And loops allow us to repeat a set of instructions without having them to write in multiple times. So it saves our work. We don't have to repeat these blocks. If let's say you want to repeat 10 times, you don't have to repeat this 10 times block. You just use forever because it will keep on looping. So this is what we call looping, yeah? And then pause is to make the microbit wait before carrying out the next instruction, okay, to hold. They are using 5 milliseconds, all right? It's half a second. And after carrying out these 4 instructions, the loop goes back to the top and then starts again. All right, so first you show the icon, then you pause for 500 milliseconds. And again, you show another pattern of the icon, okay, the image. So if this repeating, you get an animation. Okay, so you can try it out. I'm going to show you the hard code.
Property investing, Singapore or overseas? If you're thinking of buying a property in Singapore and rent it out for cash flow,
So to create our beating heart, I'm going to go to the MakeCode editor and create a new project. When you open a new project in MakeCode, you get the on start and forever blocks. We're going to use the forever block here, so I'm going to get rid of the on start block by clicking on it and dragging it into the middle. I'm then going to add some more blocks to the forever block. So I'm going to scroll down and find the heart icon. And then I'm going to add a new block, the pause block. This will make the microbit wait until it carries out its next instruction. We want it to wait for half a second before it shows the next heart image. So I'm going to change 100 here to 500 milliseconds. That's half a second. Before then showing the small built-in heart icon. Then going to add another pause block to make sure it pauses for another half a second before repeating the loop. This kind of loop is called an infinite loop, and loops are really useful in coding because they allow you to use only a small amount of code to do a lot. In this case, it keeps the heart flashing and beating forever, or at least until you unplug your microbit or click on the stop button on the simulator. I'm going to save my project now so I can transfer it to my microbit. So I'm going to call it Beating Heart. Beating Heart, click on the download button so I'll have my hex file ready to transfer to my microbit. Once you've made your Beating Heart, why not experiment with the other built-in icons to create your own animations?
Okay, so this is our animation because it's keep on looping, all right, non-stop. So right, it keeps on looping, and then that's how the animation works. Okay, the animation movie that you are looking at. All right, you can also try this, show the duck. It's a very simple exercises, duck 1 and duck 2. Okay, so animation. Congratulations, you have done this. Okay, using forever loop and sequence of instructions to make the animation, all right, on the microbit LED display. Okay, so let me just continue because don't have time here. Okay, now for lesson 3. So make sure you have this beating heart in your simulator. It's an animation, okay, by using just looping and a few of show icons. And for these lessons, we are going to show emotions, all right, share our feelings, whether you are happy or you are sad. So, well, you know, some people find it hard to express or read emotions. Okay, so and a batch like this can be helpful for them. So you can try what other inputs and outputs you can think of. All right, keys on the keyboard, a touch screen, or buttons on a game controller. Okay, the display on a phone or a game console, or sound from a phone or a game console speakers are examples of output. So we have input and output in a computer system. Input is where you are the computer are accepting some instruction. For example, button, okay, which I'm going to show you here. So in this lesson, you are going to try out the buttons.
let's start the day, shall we? For a manufacturing industry, a good day means minimal machine downtime and accurate stock counts.
Buttons are very common input devices. You will have used a power button to switch off a mobile phone or tablet, or volume control buttons to turn the audio level up or down. The buttons on the BBC microbit are input devices that can be pressed to trigger an action. You can write a program to tell the microbit what action should happen when the button is pressed, and there are lots of actions you can program. There are two input buttons on the microbit, button A and button B. The buttons can be pressed separately or together. There is a third button on the other side. That's for resetting your microbit and starting your program from the beginning again.
Okay, so I'm going to show you a simple button coding. Erase my coding here. In the make code, off purpose. Okay, so this is your button A. This is your button B. So you go to your toolbox. Okay, select input. You drag on button A, okay, you drag two, and also drag another one on button B. Now, you see, you can't be same because this one you have declared or you have used it on button A. So that's why here it has a different color. So it means that you are already using button A. So you have to use a different button, all right, which is button B. So I want to just show icon. You go to basic, show icon, and you just put it here. So when the on button press on something, I'll show a heart. Okay, so I'll try. So when I press this, oh, wait, I need to get rid of this. So in order to delete a block, you just drag to the middle, okay, and then delete it. Okay, so from my button A, okay, I show a heart. Now, if I press a button B, basic show, you can also show a string. Okay, it takes time to update. Now, if you press B, just like that, okay? So it's a bunch of instructions. So you have to give them which button that you press and then what kind of instructions that is going to be output, okay? Right, so this is buttons, input. All right, so this is my button. Now, you can also try, okay, to program a feelings, to share your feelings, whether you are happy or not.
You can use the two input buttons on the front of your BBC microbit to express if you're feeling happy or sad and let your family know how you're feeling. So if you press button A, the happy face will appear on the LED display. If you press button B, the sad face will appear. Let's open the Make Code editor and write the code to make this happen.
Okay, so you can try it out later to make the feelings. Very simple, right? This one, it's kind of sharing, okay, how you can actually use it to program, okay, your microbit. Now, this is the third bit. There's actually an icon here where you can change. There's a smiley face, if I'm not mistaken. Let me see. Yeah. Correct. If you press button B, okay, you are feeling sad. This is a sad face. Okay. If I press A, okay, you got a smiley face. If I press B, you got a sad face. So you can download into your chip, okay? So if you do not want to talk to people, just show them this one, okay? I'm sad today, okay, by pressing B or A. All right, so this is button, okay? Input is one of another important component in a computer system. Now let me show you another one for slide number 4. Link document. Now in this lesson, you are going to try to program a counter, okay? So previously in the lesson 3, okay, we use a different button inputs. And now you may also use the on shake, all right? Shake your microchip, all right? It's possible to do so. And the accelerator, the accelerometer senses when it's shaken. So this is a sensor, a kind of sensor. But this part will be covered more later by Dr. Teo. Okay, and I'm just going to cover a little concept. Okay, some basic fundamental.
An accelerometer is a motion sensor. It measures the acceleration or movement of something. A mobile phone uses an accelerometer to detect when it should switch the screen view from portrait to landscape as you move it. And game consoles use accelerometers to detect the tilt of the controller and adjust the game view accordingly. Accelerometers are also used in rockets to measure changes in speed and orientation, and in car airbags to detect a sudden change in speed, signaling a collision is about to happen and the airbag should inflate. The BBC microbit accelerometer measures movement of the microbit, so when you tilt it left to right, backwards and forwards, and up and down, the microbit knows it's being moved and which way it's being moved. The accelerometer can detect being shaken, dropped, or turned upside down, so you can use it to create lots of fun, interesting, and helpful projects. You can program the accelerometer on your microbit to create projects like a step counter, where it senses the movement of your steps and counts how many you take. You can also design and build games that respond to motion, or make a fall alarm to signal if a person has fallen over and needs help. The microbit accelerometer is a great feature to use in your interactive projects. How might you use the accelerometer?
Okay, so this is about it's very useful, okay, to sense. It's a sensor. It's a kind of sensor where you can sense different kind of movement. All right, when you shake your microbit, okay, when you want to count the steps, the watch, or even you tilt when you tilt your phone. Okay, you will be able to use it now. Another term here in programming is called variables. All right, variables. So variables is actually help us, okay, to count. It's a storage. Okay, we call that as a storage. So if you go back to your mid code, there's in this toolbox, there's this called variables. Now, to program, okay, variables is another important component that help us to count or help us to store the values that we want. Okay, the storage. You can think about variables as a storage. Okay, in this case, if let's say you want to count how many steps the user has or the person has actually walked. Okay, you can use variables to store how many steps that they have taken. Okay, they are containers, Tupperware, okay, for storing data which can be accessed and updated while a program is running. So here we are going to use this variables. So how do you do that? So first, just click on make a variable, give a name, step, okay, in this case. Click OK. So once you have the name for we call variables, it again is a container, right, to store. Then automatically they will have 3 different blocks for you. One is to set steps to something, change steps, the variable name that you have created just now, by how many, and then this is the name of the variables. So here, I'm going to use the variables that I have created. So I'm going to put it here. Steps means like before I use the step, I initialize it. I reset. Okay, I reset the steps counter to 0. Okay, everything has to start with 0, right? For these variables. And the steps variable, this steps variable will keep track of how many steps we will be taking. So in the input, all right, in this input block, there's this called on shake. Let me check, where is that? On shake, yeah. On shake means you are shaking the microbit. Okay, you are shaking the microbit. So I'm not going to use my button A and button B anymore. Okay, so today these lessons are going to introduce another type of input, okay, which is shake. Okay, you see, in your simulator, although you can't really shake physically, there's a way for you, okay, to indicate that you are shaking, right? You are shaking. You can use something like that. So when you shake the microbit, all right, so what will be changing? Your variables. Okay, it has to increase by 1. Okay, it's going to be adding. So first you start with 0. So once you shake your microbit, it will add on 1 to the variable steps. Okay, that's the meaning. And then now, just to show that the counter is correct, I'm going to have another basic block to display. So basically in this basic block is the output, all right? It's the output that is going to be shown in your microbit. So what I'm going to show? Number. Okay, which one you are going to show? I'm going to show back my steps. How many steps I have gone through, right? Okay, now let's try. That's it. And then you can test on your microbit. So if I shake, all right, it will increase to 1. All right. If I shake again, it will increase to 2. All right. Shake, 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 keep on shaking. You can also, without checking on the shake button, you can just shake your microbit. All right. And the counter keep on counting. Easy, right? So because microbit behind there's a how to pronounce that? Accelerometer. We are having problem on, yeah, accelerometer. All right, they have this accelerometer behind, okay, the microbit, which will actually sense the movement of your microbit. Okay, and then yeah, this is how you, and once you can download and then put it in your shoe and then you try to walk, okay, you can actually detect how many steps you have run or how many steps you have walked today. Now, another thing, you can also add a button, okay, for the extension of the exercises. For this one, you can try okay, download and then you put your shoe like this. And then the extra exercise here, okay, you can add blocks to show the step count when you press button A. You use the button instead of shaking. And if it's counting to few steps, All right, you can modify the code using the math blocks to fix it. Now, this math block, it's here. All right, you can use plus, addition, subtraction, multiplication, and also division. And this is the modulars. We call that as a remainder. Minimum, maximum, absolute value, square root, rounding, randomly, and so on. Constraint, okay, within a range, and randomly generated numbers. We will see one example here for this one. Pick random. All right, you can try it out later. Since okay, so this lesson is to use accelerometer sensor input that can sense when you shake your microbit to make a step counter. Okay, so let's continue with the next one, number 5. I'm just going to introduce for each lessons, and then later I'll share this with you. Now, for this lesson 5, it's about night light. Okay. This is 5. So, in the previous lessons, okay, you are using microbit to make use of the accelerometer as an input sensor to make a step counter, and we use a variable. It's a container, it's a storage to count how many steps we had taken. And we investigated how accurate the step counter was and thought about ways of improving it, and so on. Now, for these lessons, you are going to look at the light, right? The light sensors. Okay. The light sensors.
In this project, you'll turn your microbit into a night light, a light that switches on automatically when it gets dark. You'll use the microbit's LEDs as a sensor input to measure how light or dark it is. The microbit's light sensor measures light in a range from 0, very dark, to 255, very bright. You'll create a program using a loop code block to keep checking light levels. Your program will also use selection, a kind of logic, to turn the LED lights on when it gets dark and off when it gets light. After downloading your code to the microbit, you can test it out using a light source and covering the microbit with your hands or other objects. You may find you need to modify the code depending on the light levels around you to make the light switch on when it's lighter or only when it gets very dark. The next video shows you how to code your microbit nightlight.
Okay. Now, this lesson, you will be exposed yourself to selection, if else. Okay, if else. Let me check. Okay, light LED. There.
Sensor is an example of an input device which detects or measures something and responds to it. So, A light sensor responds to the level of light and usually turns a light on or off, depending on the light level detected. Street lights often have light sensors to turn the light on only when it gets dark to save electricity. While there is no exact light sensor on the BBC microbit, you can program the LEDs to detect, measure, and respond to the light level in a general way, so you can use your microbit as a light sensor. You can use this feature in lots of different programs and projects. So you could create a night light for a child that senses when it's getting dark and comes on automatically, or a light to attach to a bike or scooter or a bag to help children travelling to school in the dark.
Okay, so this is the LED, okay, in microbit LED. So it acts like an output so that
An LED is an output device that gives off light when an electric current is passed through it. LED stands for light emitting diode. LEDs are used everywhere, from televisions to mobile phones to the bright lights in your home, as they are more energy efficient, long-lasting, bright, and versatile. Because LEDs don't require much power and are small and simple, they are perfect for the microbit to use to create light. The microbit has a display of 25 red LEDs. Each one can be turned on or off using code, and so you can program the microbit's LEDs to display patterns, images, letters, or numbers. The LEDs on the microbit can also be programmed to detect, measure, and respond to light levels and turn the microbit into a light sensing device.
Okay, now, so here in this lesson, you are going to use the logic, okay, to help us to light out the LED. Okay, so this is the code, the sample code. You can, let's see. All right, using forever loop. All right, this is looping. And then as you can see here, we have a new kind of block, which consists of if and else. So this is what we call selection. So if this condition is not fulfilled or it doesn't satisfy this condition, if it's satisfied this condition, you will proceed with this execution. If it doesn't satisfy this condition, it will go to the else part. All right, if this is true, you proceed with the execution. Else, you proceed with this execution. So either one. All right, you cannot use, you cannot run both. There's only one selection. So this is what you call selection or conditioner. So here the explanation goes like this. The forever loop keeps the microbit checking the light level. And the logic here, if, then, all right, if, then, block checks if the light level is lower than 100. So you check the light level. If it's less than 100, then you will show the LED. So again, we use the accelerometer. All right, accelerometer input, which will send a shake and then change the block x1 to the number stored in the step variable. And else, okay, the light level must be 100 or more. Okay, it must be light. Then it will clear your screen, your LED screen. So you can click on this link, tutorial templates. Okay, I'm going to show you. Okay, let me try a new project. We go for that. Microsoft microbit, and then I'm going to create a new project. And I'm going to name this as, let me see.
The on
Ready for a getaway? Plan your trip effortlessly with the Trip.com app. Book flights, hotels, and attraction
Okay,
tickets.
let's name this as light
by dragging it into the middle.
sensor.
Look in logic and find the if, then, else block and snap it inside the forever block. Also in logic, find the less than comparison block.
Okay, now, so here, when you create a new project, that's the forever, right? Okay, now here I'm going to drag a if. You go to logic. Okay, there's this if, then else block. You just drag it out and put it in the forever loop because we are going to keep on checking again and again. All right. Now, remember you have the light level. All right, here. Now, in order to have this true, all right, this the condition, all right, the condition, you have to go back to the logic. All right, go back to the logic here, comparison. So you can either use equal, less than. All right, so I'm just going to use the, sorry, this one. We go to back to logic, drag it out here, comparison. Right, we are comparing because we want to compare if the light level is less than certain amount of value. Okay, so now we are trying to compare with the light level. So again, you go to input, look for light level. Light level, this one, drag it out, put it here. All right, so this one is using it to compare. So I'm using the light level. It's already been set in microbit. You can just use it. So if my light level is less than, if the brightness is less than 100 or maybe 50, okay? Yeah, let's just set 100. Then I go to my basic. I show the LED. All right, now here you can select which LED you want it to be displayed. We want everything to be displayed. Okay, so you just drag everything, select all the LEDs. Else, you just clear the screen. All right, else you just clear the screen. So here in the simulator, okay, there's an indication for the light level. So you can actually adjust. All right, you can adjust it. So if it's less than 100, you see the value, the light level is less than, now is 72. So which is actually less than 100. Now, if this is true, so this is the comparison, this is the selection. So inside the selection, you must define the comparison, the constraint, all right, 条件. And if it's less than 100, okay, your LED will light. So if it's more than 100, so this is no longer true, right? No longer true, it will go to the else block. So what does the else block do? It will actually clear your LED. So this is the logic behind if and else, all right? If and else. It's very useful. So looping itself, again, is another useful what we call component or a programming tools. Okay, looping, which is now forever. Then now, just now we look at variables. Okay, and now we look at selection. Selection, again, you can compare. You can give condition. All right, what kind of constraint will be used to compare? All right, you can also use equal, not equals to, less than or equals to, right? More than or equals to. Right? This is the what we call relational comparison. Okay, yeah? So this is if else for these lessons. Okay, you can have a look. You can also play with other parts of the component. And also you can play around with the LED light, different kind of patterns. All right, make different pictures appear if it's bright or dark. Now, if let's say you have a microchip, microbit, okay, you can cover up, okay, you can cover up with the part of the light sensors to indicate that it's dark. So if it's dark, then your LED will light up, will be lit, okay? Okay, so this is lesson 5, if else you look at, and then how you can decide which LED, okay, to light out. Now, the last lessons here is using you can use it to play with rock, paper, scissors, 剪刀石头布。没有布 sorry. It's only wait, 剪刀石头布 okay. 布 here means paper. Rock, paper, scissors. Okay, you can use microbit to do that as well. So in this part, we are going to look at how to randomize. All right, randomize the numbers. So again, for the previous lesson, we coded our microbit to make a light, okay, that switches on when it gets dark using sensors and logic. And today, for this lesson, we are going to use the accelerometer sensor. Again, we use this a lot, right? Accelerometer, very useful sensor, and even more logic to make a microbit simulation of a well-known game. We can make a game, all right? You can make a rock, paper, scissors game. How? Okay, let's take a look again.
Rock, paper, scissors is a classic game of chance for 2 players. You can play it for fun, or use it to make decisions like who gets to go first in another game. Each player counts to 3 and then uses their hand to make a rock, which beats scissors, paper, which beats rock, or scissors, which beat paper. The game only works if both players show their hands at the same time to avoid one player cheating by spotting what the other player's hand is showing and choosing something to beat it. And it's only completely fair if each player's choice is totally random. In this project, we'll code a microbit to make a fair rock, paper, scissors game. We'll use computer code to pick random numbers and use these to show rock, paper, or scissors. Shake your microbit to show rock, paper, or scissors. The microbit's choice should be completely random, and it can't see what the other player has chosen. Shake your microbits on a count of 3, and you can also press the reset button on the back to clear the screen. You could use the microbit to play against a human opponent, or investigate if you get different results with humans or microbits. Which is more random? Which is fairer?
Okay, so this is a simple game program that you can actually use it, okay, in code it in microbit, make code editor. So this is how it looks like, the code. Okay, so when you shake your microbit, all right, you see outside here, it's the first layer. All right, when you shake your microbit, all right, the accelerometer sensor will sense, okay, will detect the action, shaking. Then a random number. So this is a variable. Again, variable is a container or a storage, okay, to store the value. All right, you need that because you will be using it throughout the program, right? So a random number, we use variable to store the random number generated. Okay, so the random number between 1 and 3 is stored in a variable called random number. And now, so first you decide the number 1, 2, 3, because rock, paper, scissors, there's only 3 different modes. So within these 3, okay, the computer or the microbit will generate randomly. All right, it's either 1 or this time maybe 2, all right, or again it goes back to 1, all right, random, you do not know. It picks by them, okay, in the program, the microcontroller. Now once you have decided the number, if it's 1, it means Caesar. All right, if it's 1, it means Caesar. Sorry, this is a rock. Okay, rock. Number 2 is paper. Number 3 means Elsa, is the Caesar. All right, rock, paper, Caesar. So a random number between 1 and 3 will be stored inside the variable called random number. And the logic here, if again we are using back the selection or conditioner, if, then, else. Now here we are using more than one block. You see, if, then, else. Again, if, then, else. There's 2 different blocks here, 2 different selections. Okay, so it's because we have 3 different we have 3 different selections, right? Excuse me. We have 3 different modes. Okay, 1, 2, 3. 1, rock. 2, paper. 3, Caesar. So in that sense, we will be using 2 different blocks. If random number is equal to 1, I will show my rock. Okay. Else, if the random number is equal to 2, I will show paper. Now, how about number 3? You do not need to use another if else. You just use else. And you don't have to specify the condition or the comparison, because it's the leftover, because you already compare 1, you already compare 2. The leftover right now is only 3. Okay, what is needed to be compared? What else is only 3, right? So else, you show the Caesar icon. All right, if number 1, show rock, number 2, paper. Otherwise, okay, it must be 3 already. So it will show your Caesar's icon. Now let's try very fast coding here. Let me show you. Okay, let me go back. Okay, just click on microbit to go back to the first page. Start a new project. I'm going to name this as rock, paper, Caesar. Okay. Wait. All right, it comes to here. Now, I'm going to, you can just put it here or you can just delete it. Okay, I'm going to delete this on start as well. So I'm going to use on shape. So it's an input. It's a kind of input. Dragging out on shape. Now, before that, because I need variables, storage to keep the random number, right? So I'm going to set this as my random number as my variables. So once you have that variables, okay, by automatically, they will give you 3. Set, change, random, okay, the number itself. Okay, now, so I'm going to set my random number, okay, to 0. It's not to 0, but it's either 1, 2, or 3. So by that one, you can go to the math block, okay? Pick random here. Just pick random, put it here in this slot, and change from 0 to 1, 10 to 3. Okay, pick either one among these 1, 2, 3. And then you start to compare. Okay, you start to compare where you're using the logic, which is if. You see, there's two different blocks. One is just if, then. Another one is if, then, else. I'm going to use this, drag it out like this. So again, first I compare with my random number. So you go to your variables, drag out these random numbers, put it inside the true condition. Okay, if random number is equals to, oh, okay. Now here I make a mistake. Why? Because I need to compare, right? It's not only the variable itself. So what you do, just go back to your logic. But before that, okay, let's see. Before this, you just drag it out, delete that. So because this is only one comparison, now, because I need two comparisons. This one, I need this two. I need this two. So I need to at least drag out and put it in this slot, so that I can put back my random number inside the first. Oh, wait. You have to be careful again. Slot it nicely. Go back to your variables. Okay, make sure the red dot is linking. Then you can just, tag on that slot. And the first one is equals, right? If my random number is equals to 1, I'm going to show my icon. You can just show your icon. This would be represent a rock. And I'm going to use a small one, right? A small one, rock. Now again, else, I need another block of if, then, else. So what I do is, if, else, if this is true. Else if else if, okay, I think we can basically do that. The else is, and again, I go to my logic. All right, so now I need to compare number 2. Go to your variables. Variables, if it's equals to 2, you show your icon. This would be your rock paper. All right, lastly, it's the Caesar. Do I have a Caesar? There, this is the Caesars. Just like that. Yeah. Then you have your rock, paper, scissors. And let's see if I shake it. It's paper. So this one you have to play with another opponent. You must have like 2 to have more fun. Shake, 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 shake. Okay, Caesar this time, and then shake again. Okay, then you can download and then deploy it to the physical part. to have fun. Ooh. All right, it's pretty easy, right? This one. Any question? So you can basically do a lot of different activities, okay, using this microbit. It's a tiny computer. Just imagine that this is a tiny computer. Okay, so if there's no question, I think I have done my part. I'll pass. I'll pass the next. I'll pass to the next expert. Okay, to explain, to discuss further about the sensors and actuators. All right, thank you so much for listening. I hope you learned something from this Microsoft Make code. I'll share the slides with you all later. I think I'll send it to Mr. Yo, right? Mr. Yo. Okay, I'm done. Thank you so much.
Also, there's a question in the chat. Maybe later you can answer
There's a
from
question.
the Zoom chat. Later you can type it over
Okay,
there.
okay.
Okay, so I will take over the sections. Okay, so before we go into the next section, maybe we just take a like 3 minutes break. Okay, 3 minutes break before we go to the next sections. Okay, so in this short break, right? Okay, because my section I'm going to use another simulation tools. Okay, so you actually need to create an account for that. So during this break, okay, I will share my slide now. Okay, I'll put in the link. Okay, so from the Zoom chart, you can see that that is my slide. Okay, so you can refer to slide number 18。OK，第十八个 slide。OK，你可以看那个第18个 slide 过后，在这个短时间的 break 里面，你们可以去sign up 一个 account。OK，然后我们会继续下一个 section。OK，so 我们take a short break。OK。
Dr. Teo,
嗯
the chat,
The Zoom
the Zoom. Oh, okay. Okay,
Yeah,
wait,
yeah.
I'm looking for
Okay, I think we can start 了。Okay, so hello 大家好，这里是我是 Dr. Dio，你可以叫我张老师，也是一样的。所以说现在我会继续第二个 sections，so 我会 more on 说一些sensor 跟 actuator 的，比较in depth。OK，for 这个sensor actuator 的，so 我会讲 more on 在embedded system 的，so 我们在 start 之前OK，so 可能哎我会做一个很短的一个 survey，所以我要看你们 whether 对这个 embedded system 这个词到底你们有多了解，是否你已经知道了，还是有多了解？OK，so 现在我要做就是一个很短的一个 survey，所以说你只是需要一个 browser 或者你的 handphone 你是可以。所以说现在我 share 一下子，这是很短的，我要知道一下。OK，边 OK。所以说你们只是需要开一个 browser，过后去这个menti.com，这打 menti.com，还会直接问你的 use code 是什么，给你把这个 use code 打进去，过后我只有3题 question 而已，OK，只是要知道一下你们的对 embedded system 有几了解，OK，所以说等下我会大概 adjust 一下我的看你们的 response 是什么，可以等下大概我会adjust 一下我的讲课。OK，所以说你们去我看到一个很好。OK，所以说你只是要去开一个 browser 或者用你的 handphone 的 browser 也是可以，去 menti.com 再把这个 use code 放进去，过后你只是第一题 question 是 I'm familiar with the concept of embedded system。OK，然后第一个是 yes，开呢就是好懂一点不懂一点，不是很懂是完全不懂。OK，所以说呀，给你们1-2分钟。OK，呀。这是第一题，第一道 questions。So 第一个 question 是 I'm familiar with the concept of embedded system。OK，so 给2分钟你们作答。
哪一个 website 啊
website 是上面那个 menti.com，我的 share 群在最上面这里有
？OK
写
OK，
的。OK，大部分人都不是很懂 embedded system。OK，可以。OK，现在有44个人、45个人进来了。OK，有35个人已经作答了。有一个人懂，很好。OK，多1分钟，我会去下一题。OK。I have to get my parents approval。OK，所以 OK 可以，我只要这边看到3个很懂，OK 就当做一个复习了，OK，只是要 section 当个复习，所以大部分人都不是很懂，很好，这个是一个很好的一个 section，所以说等下我 hopefully 你们会学到东西了，OK，下一个 let's go to next question，下一个。OK，下一个是 I have experience in interfacing embedded system with sensor。OK，sensor 就是那些刚才来多多少有讲那些 accelerometer temperature sensor light sensor 已经有用过的。OK，用 Arduino 也好，用 Microbit 也好，用 Raspberry Pi 也好，OK，你们已经有懂得把一个 sensor 接在，对把 interface 用 wire interface 在embedded system，embedded system 可以说就是 either 是 Microbit、Raspberry Pi，或者是Arduino，OK，有不少人有懂这样 interface 的，OK，很好。有一个问题是订个 cat，订个 cat 你只需要用你自己的一个 email，什么 email 也还可以了，不一定要 Gmail 的，什么 email 也可以。只要如果自己没有 email 啊，可能你可以问你的父母，可以给他切一个 email 来 login 哦。OK，还是如果今天做不到的话没关系，因为这个是录着的嘛，所以说等下可能 after this section 你可以再试试看。OK。OK，so 有12个人，OK，大部分人都不是很懂，OK，不用紧，只下跟就是讲这些东西，OK，so 第二个 questions 很简单，第二个 questions，so I have used the embedded system to build an IoT project，OK，IoT project，IoT project 就是你的那个 embedded system 可以把那些资料把它送上网，IoT project，Internet of Things 啊，OK，不懂你们懂不懂？OK，I think 我觉得 Internet of Things 应该是quite common 的。给 Internet of Things 就是说，怎样把数据放上网，OK，怎样把那些数据从 embedded system 得到的数据，sensor 那些数据，把它放上网。OK，多1分钟。OK。OK，所以说可以看到有些人已经有做过了，很好，就是你们学校已经开始有教了，可大部分还不懂没关系，就是希望这下的 sections 就是你们会懂这些 concept 了。OK，当然是你要教完全部的话，可能你需要学更长时间。不过这样的下那个 section 最好是我能希望就是你们可以开通你们一些这些视野啊。OK，所以说你们只要学东西可以自己再摸索，继续摸索。OK，所以说就是谢谢你们的答问。OK，现在我知道就是不是很多人懂 embedded system，什么是 embedded system，可能你们都是懂用 programming 来写一个 program，可是 programming not only to write a program OK，programming 可以其实可以控制一个 hardware 的，可以控制一个实体件的，OK，可以控制这实体就是控制一个 hardware 的。OK，所以现在我就给你知道，OK，so OK，现在我会换回英文。OK，so let's go to the slide. OK，let me turn off my camera. OK，let's go back to the slide. Thank you for answering this. OK. Okay, so in these following sections, I will continue with this title, with the same title, okay, from code to circuits, exploring sensor and actuator with microbit. So I'm Dr. Teo, you can call me sir. Okay, it doesn't matter, or you can call me Zhang Laoshi also can. Okay, so for the next sections, okay, this is our outline. So first of all, is instructions to embedded system, then understanding what is sensor, what is actuator, and then I will introduce to you the microbit. Just now Dr. Soko introduced you a bit already, so I will further introduce more about this microbit and also the Tinkercad. So just now Dr. Soko, she is using MacCode, I will using Tinkercad because Tinkercad can interface with the virtual sensor. So that I will be teaching you another one. It's called Tinkercad, and then we will do some guided simulation activities, and then I just set up a mini challenge for you to try it out. And then we have a wrap up. If you have any questions, you can ask. Okay, so meanwhile, I'll also checking the meeting chat if you have any question about this section what I'm explaining, you can always ask in the Zoom chat. Okay, so let's get started. So what is embedded system? Okay, so just now I see not all of you know about embedded system. So there are a lot of definitions, okay, about embedded system. So for a general one, so embedded system is a computer designed to perform a dedicated function with a larger system. Okay, sometimes embedded system can perform a single task only. For example, you vacuum, okay, with vacuum cleaner, only single task. Okay, but some of embedded system can perform more than that. More than that, just now Dr. Soko mentioned, game console can perform more than that. Okay, it can be perform more than that. So it depends. Okay, embedded system, they have a lot of them. Okay, a lot of different kind of embedded system. Just now vacuum cleaner, your TV, your washing machine, these refrigerator, they are all embedded system. Okay, so these embedded system, they are designed. Okay, they are actually specialized for specific tasks, often real time and reactive. Okay, with the combination of hardware and software, they are real time, which means that when you're using vacuum cleaner, when you press the on button, the vacuum start to spin. Okay, it won't like delay 1 or 2 seconds, right? So it's not like our computer, our laptop, or the tablet. When you start the program, it may take 1 or 2 seconds, then only start it up. Okay, but for embedded system, they must be in real time, because sometimes embedded system can be like used in it may save life. Okay, so what I mean save life, for example, in your car, when you press a brake, the embedded system must know that you are pressing a brake, then the embedded system must brake the car, must stop the car. It cannot like delay 5 seconds, only stop the car, then you know what's happening already. Yeah, so this is what we call real time. Okay. Okay, so next. So concept of embedded systems. So just now I mentioned a little bit already. So for embedded system, usually you have one microcontroller. It's a brain. In our desktop, we often call CPU, Central Processing Unit. This is called CPU. So in the microcontroller, in the embedded system, usually we will call microcontroller or microprocessor. That's a brain to process all the data. Okay, and also in the embedded system also have a memory. Okay, memory to store the code. Okay, because we are coding, right? Just now you see Dr. So actually download a hex file. That is the instruction that you need to store inside the embedded system, and the embedded system will run according to your instruction. That is the memory to store the code. Okay, they also have some memory like a RAM to store the immediate data to processing that. For example, just now a random number have a variable, right? All these are stored inside the RAM. Okay, so that's the memory. Other than that, you have sensor that gather information. Sensor like light sensor, temperature sensor, moisture sensor, humidity sensor. These are the sensors that gather this information. So after you have gathered this information, where they go, okay, this will be processed by the microcontroller and react accordingly by using actuator. So just now you see that when the light sensor sense that the surrounding is dark, what happened to the LED? LED will turn on. So LED is actually part of the actuator to perform some action. Motor also part of the actuator, it will spin. For example, the temperature is very hot now, it's very high now, so it will actually spin the motor, automatically spin the motor so that it can actually cool down the surrounding. Okay, so other than that, everything else need power to run, either by using, just now you can see, the microbit can just use a cable connect to the laptop, it can power up already, or by using a battery. So that is another beauty of embedded system, because it can power by battery. Okay, but how about, if you want to compare embedded systems, later I will say about that. Okay, later I will say about that. So let's see about real world example. Okay, so these are the real world example. I think 1 or 2 you already see before. Okay, microwave oven inside is embedded system. Okay, timer and heating control must be in real time and precise. You set it 10 seconds, it must be 10 seconds only. Okay, you cannot like set it 10 seconds, but it hit for 20 seconds. Then you know what's happening to your food, it will burn already. Okay, they must be in real time. So there are a lot of concepts, a lot of fun things to learn about embedded system. Okay, other than that, you can see there's a smart thermostat, which is to monitor and adjust the temperature. You have an automated door lock. I think this one mainly used in condo. If you are in KL, I think condo mainly use this automated door lock. It's by using RFID to unlock the door, or by using PIN to unlock the door. Other than that, you can use the fingerprint. You can see the routing here, right? This is using fingerprint to unlock the door. So this is also part of the embedded system because this is actually powered by battery. If you see this door lock before, right, there's a battery pack down here. Okay, so it's powered by battery. Other than that, car airbag system. Okay, you know what is airbag? Is to detect, impact, and deploy the airbag so they can save your life. So this must be in real time, must be deployed in millisecond, so you can save your life. Okay, so these are the example. Okay, just one of the some few examples about embedded system. So just now I say about what is different between embedded system and the general purpose computer. General purpose computer like a desktop, gaming desktop. Okay, gaming desktop, gaming laptop, okay. Then what is this compared with the embedded system? So for embedded system, usually it's specific tasks only. Okay, specific task. For example, vacuum cleaner is to vacuum. Then oven, just like microwave, is to heat up your food. And then fridge is to keep the things cool. Okay, they are specific tasks. For general purpose computer, like laptop in front of you, what you are doing, you are actually running a lot of different software, multiple tasks at the same time. Okay, maybe you're running another screen, okay, looking at another website. So they are all multiple tasks. Okay, so for embedded system, usually it's small and compact. Yeah, if you then you will ask, hey, fridge is so big, why you say it's small and compact? But yeah, if you happen to open the what is called the box behind, right, you will actually see actually it's very small only. Okay, the embedded system is very small only. Why the fridge is very big? Because you need to have some capacity to store the food, right? That's why it's very big. It looks big, but the things that controlling the cooling system, right, is actually quite small and compact. Okay, so for comparing with general purpose computer, as you all know, you can see the gaming desktop or your laptop. You can see it's quite big, it's quite large. Okay, so other than that, operating system, you know what is operating system? Your Windows, Mac OS, these are called operating system. Okay, the operating system. So for embedded system, sometimes most of the time now, okay, there's no OS. There's no OS. Okay, sometimes they have a very light OS. So just some of you got deal with IoT project before. Okay, if you are using, just like I mentioned, Arduino, right? This Arduino, okay, there's no OS. So Raspberry Pi, I think, is quite common now. Okay, this one have OS inside. It's actually running Linux. This is an NVIDIA Jackson, also running Linux. There's a lightweight Linux, and the microbit, actually there's no OS. Okay, you just need to put the hex file inside, and it automatically run your hex file, your instructions already. Okay, that's been my OS. And then we have a full features for a general purpose computer. You already know the laptop you're using is the Windows. Okay, maybe you're using Mac OS. Sometime if you're more hardcore, maybe you're using Linux. Okay, that one I will respect you already. Okay, you're using Linux for general purpose computer. Okay, so other than that, tablets. Okay, tablets, your handphone. Yeah, I think there are only two operating systems for this tablets or handphone. Okay, first is the Android. Okay, first is the Android. Second is Mac. Okay, I think it's a Mac OS. Yeah, it's Mac OS. Okay, so lastly, embedded system is their energy efficient. Okay, the energy efficient. This is correct. This is very true because the most good example for this energy efficient is your fridge. Okay, did you turn off your fridge? I mean your 冰橱, okay, refrigerator when you go for 2 weeks vacation. Yeah, some of you may turn it off okay. So but most of the time you will just put it on. Okay, you can see they are quite energy efficient because you are turning on for 24/7. I mean every day, but it does not shock your bill. Your bill will not be very, very expensive. It's still, that's why it's very energy efficient. Okay, but for another side, for the general purpose computer, it's very power intensive. Like a laptop, maybe 2 and 3 hours, then the battery run out already. Okay, and if you somehow found you have gaming desktop, you're actually using 600 to 700 watt power supply, it consumes a lot of power. Okay, so that's just a simple comparison between embedded system and general purpose computer. Okay, so the next thing is why you want to learn embedded system. Okay, so nowadays embedded system cannot run away. Okay, there are a lot of applications in IoT, robotic, and automations. Smart home getting more common now. Okay, maybe your house have a smart home system. My house also have a smart home system. You have a central processing unit. They have a center hub so that all the sensor, like a door sensor, which is a magnetic sensor, motion sensor, light sensor, they are all connected to the central hub. These are all embedded system. Okay, and it's actually an IoT system because I can see it when I'm outside the house. So they cannot run away, okay? All these already involve embedded system long time ago, actually. Okay, so you also have high demand in industry, automotive, and healthcare, and also agriculture. So agriculture, yeah. So it's part of your part of the hackathon. Okay, so it's a foundation for learning microcontroller. If you want to start something small, learn from microcontroller or learn from embedded system. So embedded system, since it's a hardware, okay, you have hands-on. You are touching the stuff. You are touching the hardware if you learn embedded system. So it's different from software. Okay, software is when you run it, it's run in the computer. Okay, you actually cannot touch it. Maybe you can touch the screen. Okay, if you consider that as touching. Okay, else, yeah, it's software. You should most of the time you cannot touch it. But embedded system or hardware, this microcontroller, you can touch it. Just now, but also show you the microbit that yes, you can touch it. Okay, that's the embedded system. Why you want to learn it? Okay, so that's all about instructions to embedded system. Okay, so I'll talk about sensor and actuator. So there are a lot of story about this sensor and actuator. I'll just make it general and make it simple for you to learn. So what are sensor and actuator? So sensor is like a device that detect and measure the physical property. Okay, anything around us, they are all physical property. For example, temperature, light, humidity, gas, smell, they are all physical property. Okay, this is a physical property. How the embedded system or any computer know, okay, kind of like know the physical property. How they know? They need something, some devices help them to convert physical to digital. Because, computer or any embedded system, they are all digital. Okay, they're all digital. Anything that like you're running the software now, they're all digital. Computer or embedded system can only understand digital. That's why you need something, it's called sensor, to convert all these physical property to a digital thing so that it can be read by the embedded system. So this is called sensor. Okay, so next, actuator. Actuator is a device that receives a signal and performs the physical action. Like for example, turn on the light when the surrounding is dark. How the embedded system know the surrounding is dark? Because it has a sensor, it has a light sensor. Light sensor can measure the surrounding brightness. If it's fall below a threshold, it will turn on the light. I think this is quite common. Maybe your house also have this kind of sensor. There's a ceiling light. When you pass through a ceiling light, you pass through some light, it will automatically turn on. Right? I think if it's not in the house, maybe in the hotel, you will see this kind of motion activated light. When there's a motion, you activate the light. So motion is part of the sensor. When you detect a motion, it will activate the light. Why you have this kind of smart device? Because it can save energy. It can save electricity. Because sometimes you don't want to turn on the light 24/7. You only want to turn on the light when someone is there, right? Then you only turn on the light. Then you can save a lot of energy, right? Okay, so the analogy, you want to link the sensor actuator to our humans, right? So sensors are like a sensors, like our eyes and ears. What our eyes can see, we can see anything, see the visuals, see the image, see anything in colors and so on. They are the sensors. Our ear can actually listen. Okay, and of course, other than that, our skin, also power sensor. What your skin can do, you can sense whether it's cold or hot, right? That's sensor as well. And also actuator, like our muscle, our muscle can move around, we can grab the things. Okay, if we are feeling cool, what you will do, you go and get a jacket and wear it, something like that. Okay, so that's actuator, like our muscle go and do something. Okay, so what are the common type of sensor? So maybe in your hackathon, because it's agriculture, so you may think of which sensor is suitable to be used in the agriculture. Okay, so you can search online. I believe that it can give you a lot of suggestions on which sensor you're going to use in your hackathon. Okay, and then pick the one that you think is relevant. Okay, pick the one that is relevant to your hackathon, also relevant to your strategy. Okay, don't pick the sensor that suggests from internet that at the end is not relevant to your strategy. So pick the one that relevant. So these are the common sensor. Okay, first of all, temperature sensor is very common to measure temperature, measure the heat, measure the temperature. Agriculture, I believe temperature sensor is actually quite important, okay, to measure the temperature. Because if it's too hot, the plant will somehow not able to withstand, then it will die. I mean, it will turn yellow. So what you can do with temperature sensor, if it's very hot, what you can do, you can combine with an actuator, which is the water spray, something like that. Then it will start to water it, then it cool down the environment. That's something like that, just an example. Someone is writing, okay. So other than that, light sensor, okay, light sensor is to measure brightness. So what you can do with light sensor is to, for example, turn on, maybe you have a greenhouse, you can use a light sensor to turn on the surrounding when it's dark. So when it's bright, then you will turn off the light. So light sensor can be automated. You don't need to like every night, every day when it's done dark, you need to have a labor, go and switch on the light. Okay, then although it's not a very tedious job, but you still have someone, you need to have some labor, and you need to remind him or her, hey, now it's 8 p.m., it's very dark, go and turn on the light. Okay, why not we invest a light sensor, so if it's turn dark, it will automatically turn on all the light. Something like that. Okay. Then motion sensor is to detect motion. Detect motions, it can be applied in a lot of different things. For example, turn on a light when there's a motion, or sound the alarm there's a motion. You can do that as well. Okay, sound alarm when there's a motion, because this was security purpose. Lastly, sound sensor is to detect loud, is to detect sound. Okay, these are common type of sensor. Of course, there are more than that. But just give you overall idea, what are the common sensor out there. Okay, these are the affordable and easy to use. I believe also easy to interface with the microgrid. Okay, later I will show you some pictures of how they interface together. So just now I'll give you some ideas of how these sensor and actuator work together. So just now we have a sensor, like a light sensor, it will sense the surrounding brightness. Okay, when it's turned dark, this brightness, actually brightness is in percentage. Brightness is in percentage. So this brightness was sent, this data was sent to the microcontroller. Microcontroller will know that now is 50% only. The surrounding brightness is 50% only. And then if it's fall below 60%, there's an if else. Of course, anything also involve programming concept. I believe if you are in this hackathon or in this NSPC, your programming concept should be at some level already. Okay, so it's just a if else. If the light brightness is less than 50% or less than 60%, then what you will do, turn on the light. Okay, else turn off the light. Okay, so the if else, this logic, where to actually run this logic is run in the controller. It's run in the embedded system. Okay, run in the microbit for this case. Okay, so this microbit have the logic to get the sensor reading, check whether the condition is true or not, like for example, less than 60. Then if it's true, what it will do, it will control the light to turn on. Okay, so this is how you do sensor, controller, actuator. Okay, so sensor actuator, I'm not sure you know or not, they are digital analog. Okay, why I want to mention about this, because later you may confuse if I say digital or analog. So I will just very go through, okay, what is digital analog? Okay, so for digital signal, there are only two possible value, only two, 0 or 1. You can actually interpret like 0 is off, 1 is on. You can just interpret like this, 0 off, 1 is on. So it's, for example, like turn on the light, right? If it's 0, it will turn off the light. Okay, the logic is 1, then it will turn on the light. Something like that. That's digital value. Only 0 and 1. There's no 0.1, 0.2, 0.3. No. For digital, only have 0 and 1. Then for analog, it's a range of value. Okay, in a range of value. This one, it will involve ADC. Okay, ADC is another story already. But just assume that your microcontroller can read 0 to 1023. That's the reading. Okay, so actually 0 means 0 watt. 1023 means 5 watt. So 0, this kind of watt kind of things, right? I think if you are from science stream physics, yeah, you know what is watt. What is watt? Watt, okay, what is watt? But watt is actually cannot really read by the microcontroller. Okay, microcontroller can only read digital number. What is some electric signal? This cannot be read by the microcontroller. So that's why they need to convert to some digital numbers, which is 0 to 1023. So this range of 0 to 1023 is the one that you can actually read it. Okay, you can actually read it and then perform some actions accordingly. Analog signal is in our laptop, right? Laptop, if it's analog signals, if you say to power up your laptop, yes, it's analog. Okay, but anything that show on the screen is digital. They're all digital. Okay, so let's move on. Okay, these are the difference. Okay, sensor have digital and analog. Okay, actuator also have digital and analog. Okay, I will just briefly tell you, hope you can get my meaning now. Okay, so first of all, the digital sensor have, these are just an example. There are a lot of different kind of digital sensor. Just give you some example. First of all, PIR motion sensor. So this one is a motion sensor that sense when there's a motion, your microcontroller and the embedded system will read a 1. Okay, because sensor is the one that sense the surrounding and send the signal to the embedded system. So this signal, okay, just as I mentioned, this signal can be digital or analog. If it's digital, the microcontroller only will receive 1 or 0. That's it. Whether it's 1 or 0, that's the embedded system will receive. But if it's analog, the microcontroller will receive the range of 0 to 1023. Okay, so back to this digital sensor, which is PIR motion sensor, right? So when there's motion, your embedded system will receive a 1. Okay, so if there's a motion, the embedded system will receive a 0. So for example, like a button also, when you're pressing, then your embedded system will receive a 1. If you're not pressing, you will receive a 0. That's digital sensor. During the competitions, will there be questions surrounding this? Or I think the hackathon is for you to, how to say, for you to explore. We didn't ask you any questions, okay? So you need to explore, okay? Go and explore the possible solution and then compile it, link all the parts that make sense together and then present to us. I think more on this, maybe you can ask Mr. Yo on this. Okay, let me continue. Okay, if it's a question about competitions. Okay, so back to this analog sensor. Analog sensor is a range. Like I said, it's a range. Okay, so for this range, right? Okay, it will be percentage. The light is actually in percentage. If it's 0%, means it's very dark. 50% is like normal. It's like normal surrounding. Okay, if it's 100%, it's like spotlight already. Okay, so this is the range. If it's analog, there's a range. If for digital, only have 0 and 1. So for temperature sensor, also there's a range. Okay, you know our temperature sensor have, our temperature have 35, 36. These are the range. Okay, so these are the analog sensor. So for this won't be any question on this topic. This is not an exam, okay? This is not an exam. So I won't ask you questions about this. Okay, so this is like for you to learn. This is not an exam. Okay, don't worry about that. Okay, so next, actuator, digital actuator. So LED is on and off. Okay, so it's a digital. If you send a 1, it will off. Okay, so if you send a 1, it will on. Then if you send a 0, it will off. Like water valve, for you to water the plant. Actually, I have a system. Okay, I built myself. I guess it's a very affordable and very easy to build up. If the moisture sensor lower than a threshold, it will turn on the water valve and water my plant. Okay, and then we have that's a digital actuator, just only on and off. Okay, it's not like water valve on halfway. Okay, no, the water valve can fully open and close, right? It's not like you can on like halfway. No. Okay, it's either open or off only. So for analog actuator, so by DC motor can control the speed, right? Motor have a speed, either full speed. You can, of course, DC motor, you can put it full speed or stop. Okay, other than that, you can do like 50% speed. Motor can do that. Okay, motor can do that. And other than that, buzzer also using analog. Buzzer, why is analog? Because you can play around with the frequency and you can hear different sound. That's the analog actuator. Okay, so these are the terminology. Okay, so just later I will say digital, then you know that what will expect, what is the signal you will expect. If it's analog, then you roughly know what is the value you will expect. Okay, so let's move on. Okay, officially move on to microbit and Tinkercad. Okay, so microbit also already introduced to you. So for this one, I will more on introduce to you more on hardware. Okay, so for this part, you can see that these are all the hardware you can harness. So in your project, if you think that some of the hardware is part of your strategy, you may emphasize this. You can emphasize it. Just for example, so for this microbit, this version 2. Okay, so from the exercise in the earlier this day, you will see that there's an LED. Okay, this is actually a touch sensor. If you really have the hardware with you, you can touch it. It's like a touch sensitive. It's like a switch, but it's actually a touch sensitive. Then you have a button A for you to press, button B is for you to press, and then you may ask, sensor and actuator, where can I connect? Yes, for this microbit internally, it already have some built-in temperature and light sensor. Just now Toto already mentioned, inside already have a sensor. But sometimes if you think that this sensor is not enough, I want to connect another temperature sensor, which is externally a sensor connect using a wire interface with this microbit. Can you do that? Yes, you can do that. Okay, so like I say, this is built-in. They already have a built-in temperature and light sensor. But what if you want to connect extra sensor? So where can you connect? Is connect by using this Go pin or piano. Is it piano? Piano pin GBO. Okay, it's called general purpose input and output. Input and output. This is what you can connect. Then from here, you only can see 0, 1, 2, right? Then you may ask, hey, so only 3 sensors I can connect. Is it like that? No, actually, you can see these are the big hole that you can use crocodile pin or banana clip. You can clip it and connect to a sensor. Or you can see there are some smaller pins here, right? You can also use this to connect to more sensor. So for this small pin, these are the data sheet. Okay, these are data sheet. Okay, the big one. Okay, the big one. Also, where's my mouse? Okay, the big one is what I call P0. It's for you to connect to sensor. But if you want to connect more sensor, you can connect to this small pin. Okay, so other than that, if you flip behind, you have a USB reset pin for you to connect battery, so on and so forth. Okay, so you may ask, how do I connect? Okay, so I have pictures for that. So for you to connect extra sensor, sometimes we will use, if you just want to use crocodile pin and connect to this microbit, yes, it actually works. Don't worry. Just that if you want something like easy to use or something easy for you to expand, there's an expansion board called Recabit. Okay, you just need to slot it into it. Then you can, this is an example. This example is this thing is powered by a battery. Okay, this is like a garden helper, okay, to water the plant. Okay, from here you will see there's a motor, there's a pump here inside the cup. There's a pump, there's a moisture sensor. This is actually a moisture sensor. Later I will explain. It's a moisture sensor. This is connect to one of the pin here. Okay, so for this case, it just connect only. It don't need to cut the wire, no need to do any soldering kind of things, no need. Okay, if you have this kind of expansion board, just to buy a correct sensor and just connect like this. So for this case, I believe you already know, the sensor is a moisture sensor. Soil moisture sensor, it will sense the moisture. If it's below a certain threshold, okay, it will turn on the pump to water the plant. This is automation. Okay, so the next one from here is another project. I mean another sample, another example. This is a temperature sensor. Okay, so just like I say, built-in, already have a built-in temperature sensor. But sometimes if you think that the accuracy is not that good, you may want to use external temperature sensor to have higher precision, higher accuracy. So this is how it connects to an external temperature sensor. And then for this microbit, how do you read the temperature sensor? How do you know the reading of this temperature now? Like I said just now, you can actually output it by using the LED, or you can connect to the LCD. This is a simple 16x2 dot matrix LCD. So you will see the temperature readings here. Okay, other than that, this is a robot. You can use it to control a robot. Okay, there's a distance sensor in front, and this 4 of this is connected to a motor. Okay, all of this, they have a video. You can look at this. You can try to relate, okay, how this can be used in your project. Okay, so let's start to do something already. Okay, I think still have time. Okay, let's start to do something already. So like I say, we will be using Tinkercad. Tinkercad is also another simulation tools. Okay, Tinkercad is another simulation tools. Mainly is for 3D design, 3D model design. After you have done that, you can actually use 3D printer to print out your 3D product. Okay, but other than that, you also have this Tinkercad circuit for you to simulate your circuit. For you to simulate, like for example, you can see from here, this is a microbit, connect to a buzzer, connect to a motion sensor. We will do this later, okay? So whatever you connect like this, if it can run in this simulation, and you duplicate it, you mimic it in the real world, use a real microcontroller, connect to a real buzzer and connect to a real motion sensor, and also if you simulate correctly, it 100% work the same thing in the real world. Okay, that's the beauty of Tinkercad. You can simulate it first before you go and buy the hardware. Okay, that's the beauty of simulations. Okay, you can quickly prove your concept. If it's working, then you only go and buy the hardware and connect accordingly. Okay, that is the Tinkercad. Okay, so next slide. This is just now before the break. I already told you to I told you to create an account. If you cannot do it now, it's okay. Like I said, it's recorded later when you are free. Okay, you ask if you don't have email, you can ask for parents, create an account, then you can continue from the following guided activity. So I have a total of 6 guided activities. It's a very simple one. Okay, it's a very simple one for you to explore how do you actually interface. This section is more on interfacing with external hardware, external sensor, external actuator. Okay, so because earlier in this day, you only use microbit to actually play around with the built-in button here. This is one you will play around. But now we will see how do you connect the external hardware. So usually to learn a new hardware, it seems like you're learning a new software. Okay, when you learn a new programming, where do you start? You start from Hello World. C++, Python, you always start with Hello World. So for embedded system world, we always start with blinking LEDs. This the unwritten rules. Okay, we always start with blinking and LED. So for this case, we will build the circuits like this. Okay, don't worry, I will show you step by step how do you do that. Okay, we will build a circuit like this. So there is the microbits here. You can see there are some colors here, right? These are all the wire, all the real wire. I mean, this is simulations, but when you connect in the real world, these are all the wires. Okay, this is a resistor. If you're physics students, you know this is resistor, and we have a LED. Okay, we will be connect like this and use this code, use this block programming. This is actually something like a Scratch programming. Okay, other than that, you can use Python as well. Later, I have a useful link that I will show you. You can use Python to control as well. Okay, so let's start writing this code. Okay, this code, just a very simple one. When you start it, it will bring in every 1 second. Okay, it will bring in every 1 second. For this case, you can see that digital write pin, P0 and high. So just like I say, digital is the digital because it's high, right? It's digital. So when it's high, what it will do, it will turn on the LED. If it's low, it will turn off the LED. Okay, then you may ask, why there's a wait 1 second and wait 1 second here. Okay, as you all know, okay, our eyes cannot catch a fast-moving signal or fast-moving object. That's why we want it to wait. You turn it on, yes, the LED already turning on. Can you wait for a while for us to see it's actually turning on? So that's why we have a wait. Okay, turn it on, wait a second for us to notice it, and then turn it off. Also wait for 1 second for us to actually see it's turning off. So for this case, in other words, it will bring every 1 second. Okay, in the short term, short sentence is it will bring every 1 second. Okay, let's try this one. Let's try this one. Okay, let me bring out my Tinkercad. Okay, so when you log in into Tinkercad, this is the this interface. This is the interface of the Tinkercad. So Tinkercad actually can do a lot of things other than microbit. This microbit you can see. Okay, you can interface with Arduino. Okay, you can do your circuit design. For example, you can see you can do your circuit design. Okay, and try to simulate it before you buy the real things, so on and so forth. Okay, so whatever you simulate like this, when you duplicate it by buying the same hardware, it still work in the real world. Okay, it still work in the real world. Okay, so for this case, after you log in, you should see the interface like this. Okay, after you log in, then you can see at the top right hand corner, this is my account, and this is my account. Okay, yours one will be differently. So you can start with new design. When you click on new design, it will ask you three things. Whether it's 3D design, this is mainly to build a 3D model so you can print by using 3D printer. I've done it before, it works, it works. But for this case, we will focus on circuits. Okay, we will focus on these circuits. So click on circuits, new design, and then circuits. Okay, you will look a while, then it will open a new interface for you. Okay, a new interface. Okay, so click on your account at the top right hand corner just now, then select new design and then select circuits. Okay, then you come to this interface. Okay, you come to this interface. I will explain in a while. Okay, so when you are in this interface, you can start to connect a circuits already. Okay, so I will just explain a little bit. Top left-hand corner is actually is your project name. Okay, so whenever you create a new circuit, it will be given a random name. You can just click on it. Okay, you can like change the LED exercise. Okay, and then they will change the name already. Okay, so this is the name of your project. Okay, other than that, the middle one is for you to place the circuit. Then the big space here is for you to place the circuit. And then you have other tools bar here. Okay, tools bar here, for example, this copy and paste, delete, undo, redo, and then put a note. You can put the notes. Okay, you can put the notes anywhere you want so that next time you refer it, you know what you are doing. And then this is the wire color. It's the wire color. Okay, and then this is the wire. And then this is, if the sensor, you can actually flip left, flip right, flip out, flip down, rotate left, rotate right, whatever you want. Okay, when this now is gray because we haven't put in any sensor. Later, when you put in a sensor, you can change, you can turn left, right, up, down. Okay, so let's start with dragging a microbit breadboard, microbit circuits. So for this case, at the right side, you can see these are the basic component. You will see a microbits here, but we are not going to use this. Okay, because if you're using this, right, you can see, for example, I don't do it. If I drag out, it's just a microbit. It didn't have a breadboard here. So to save your time, okay, to save your time, why not we drag out some skeleton. Some skeleton is already have the breadboard connected to the microbit. So to do that, at the top right corner, there is a component. Okay, for this case, click on this bar, this box here, and select microbit. Okay, so these are the skeleton. So later after this thing, okay, you can try with alarm and log, so on and so forth. You can try it. You can try it later. Okay, so now let's take the first one, the breadboard. Take it out and put it here. Okay, so for this case, this is skeleton that the microbit already connected to a breadboard. Okay, breadboard, it needs some knowledge to use this breadboard, but for now, just follow whatever I connect from the slide. Okay, just follow exactly the same. Okay, so for this case, this breadboard, I mean, if you are a physics student, do you learn breadboard in physics? But anyway, okay, this is a breadboard for you to put your sensor, for you to put your push button, for you to put your LED. These are what you call breadboard. Okay, so for this case, you already connected power to this breadboard. So you can see that this line, this row here is 3 volt. If your sensor need the power, you can connect to any pins from this row. Okay, so you know that power have positive and negative. Electricity have positive and negative. You have negative as well. Okay, negative. So top 2 row positive and negative. Bottom two rows also have positive and negative. Sorry, this negative and positive. So they have creativity. How do you want to connect the sensor? Okay, so now we want to connect a LED, an LED with a resistor. Okay, why you need a resistor? If you don't do that, it will burn the LED, okay? Because LED cannot take in a big electricity, okay? Big electricity, else it will burn. That's why you need a resistor to resist, to lower down the voltage. Okay, that's another story already. Okay, so now click on, okay, at the right hand side, there's a box here, click back the basic. Okay, click back the basics. This is a guidance, you can do it, we can do it together. Okay, click the basic. Okay, and then take out the LED here, take it out, just drag and drop here. LED, okay, LED take it out. Resistor, also we need one, drag it out like this. So resistor, you know that resistor have different value. You will have a different value. So if it's one, this by default is 1 kilo ohm. 1 kilo ohm, you can see the color is like this. Okay, it's exactly the same color with the real resistor. Okay, so for this resistor, we want to use only 330 ohm. Okay, 330 ohm. So first of all, change the ohm. You can change to ohm only, milli ohm, micro ohm, nano ohm, pico ohm. Okay, kilo ohm, mega ohm, and giga ohm. So we only use ohm. And then this one change to 330. 330. Okay. Then you can see the color also change to 330. This is the color represent 330 ohm. Okay, for LED, if you don't like, for example, you don't like red color, you can change to other color. Okay, it's up to you. Okay, so for this LED, okay, LED actually have positive and negative. Okay, positive and negative button. For now, just connect according exactly the same way like this. Okay, this LED, the left pin connect to F2. There's numbers here. F is F, and this 2. Coordinate F2. Put it like this. Okay, so it's like this. Okay, put the LED F2. Put it like this. Drag and drop at F2. And the pin is connected to F3. Too much. I think we cannot finish. Talk too much already. Okay, so yeah. Okay, let's see what you do. Okay, so after you have put this LED, okay, so next thing is the register. Okay, register we're going to put in horizontal. This is in vertical, right? We can put in horizontal. So for this case, you can just use the turn, rotate here. The hotkey is R. You can press R as well. So you turn horizontal. Okay, turn horizontal and put it at I3, okay, one side of a pin of the resistor put in I3. And that's it. Okay, this is what we want to put. This is something like we connect, okay, connect the pin into, slot it into this breadboard already. We already done that. Okay, in simulation, yeah, it's as simple as that. Just put it in, then you have to slot into the breadboard already, the pin of the breadboard. Okay, so next thing is we want to connect a power. Okay, we want to connect a power, and also this LED is controlled by this microbit, right? It's controlled by using pin 0. Pin 0 will control this LED. That's why one of the pin of this LED must connect to the P0. This is the input and output. Okay, so this one, okay, all the pins here, it can be configured as input or output. If we configure as input, it can read from the sensor. If you configure this pin as output, it can light the LED. Okay, this is what you call general purpose input and output. Okay, so now we want to connect. Okay, we want to connect the exactly the same with the slide. So the left side of pin, okay, J2 connect to negative. Okay, the J2 here connect to negative, and then another side of the resistor connect J7 to the pin 0. Okay, and connect exactly the same way. Okay, so we will do it now. Okay, so when you connect the wire, right, there are a lot of colors for you to choose. Okay, so if you want to be like presentable, okay, you can choose. If it's connected to negative, you can choose black color. So just how with this one, we want to connect negative, right? So like this, just connect. Okay, click one time. Okay, I'll just show you. Click one time, there's a wire come out. You can see. Click one time, the wire will come out, then connect to any pin you want. Okay, so we connect the J2 to negative. Okay, J2 to negative. Then another side, the J7 connect to P0. So for this case, you may want to use other color if you want. I use blue color. Connect J7 to P0. That's it. As simple as that. Okay, after you connect like this, okay, I will explain first. Okay, after you connect like this, then where's the code? It's a microcontroller, right? It's a microbit. We want to write the code. So the code, again, it can be written in block programming. Just now in the morning you learn, right? These are all what you call block programming. There are a lot of blocks. But if you're familiar with Python, you can write in Python as well. Later I'll show you some useful link if you want to write. You want to learn and write in Python. But for now, I will just use block programming for easy understanding. So how do you write a code? Where is the code? Okay, so you can see at the top right corner, we have a code. Okay, and then the start simulations. So the simulation is not yet start. Okay, it's not yet start. It's not like just on the main code. It will automatically start the simulation. But for this case, Tinkercad, it does not start it automatically. Okay, so for this case, click on the code, and then these are the code. So you can see the block, they're the same, more or less the same with the main code in the morning. Just that some of the color, they are different only. Okay, the color you can see in the morning, I think on start and forward, they are white color. What's the color? Purple color, if I'm not mistaken. But for Tinkercad, the color is different, but the function they are the same. Just to let you know, the function they are same. Just that the color they are different, but doesn't matter. Okay, the color, only the color is different, but the function is the same. Okay, so for this case, we want to bring the LED. So for this forever block, do the same thing as the slide. This slide. Okay, what is meant by forever block? In the morning, you know that this is it will loop forever. It will start from the top, start from forever, turn on LED, wait a second, turn off LED, wait a second, and then loop again, go out again. Okay, so at the end, you will see the LED is blinking. Okay, let's try this one. Okay, so what you will do, you need output, create an output, and then you can see these are mostly the same with the early morning the main code lah. So for this case, we want to have digital write pin. Digital write pin, put it forever. So you can select P0, P1, P2. So for this case, we remain P0 because the LED is connected to P0. Okay, then it's high. Okay, starting with high. You want to start with low also can, doesn't matter. Okay, you want to start with low, turn off the LED. You want to start with off the LED, then turn on. You also can, because at the end, they are the same. When it's blinking, right, it doesn't know that when it starts program, whether it's on or not, it actually doesn't know. Okay, so for this case, we will start with high. Okay, we'll start with high, and then we go to control, and then control, wait a second. Okay, next, we do the same thing. Put it off. Okay, you can right click and duplicate, I think. Oh, cannot. Okay, so after that, wait a second. Okay, this is the simple circuit to turn on, to bring the LEDs. Okay, give you a few seconds, drag out this. Okay, so after you've done this, right, okay, what you will do is just after you put in the correct way, exactly the same with my code, then you can start simulation. You click on start simulation. Okay, when you click on start simulation, since it's the simulation, okay, you can see that everything come alive, even with the internal temperature and light sensor. This is the internal, you can drag it. Okay, since it's simulation, okay, you cannot put a fire, put a heat near to the laptop, right? Because because it's simulation, it's a virtual world. Okay, for this virtual world, how do you adjust double quote the light sensor or temperature sensor? Is only you can drag like this. You can see the temperature is different. It's actually changing, light also changing. And also this one you can just shake like this. Okay, this in simulation is checked like this, or you can do like dropping. Okay, dropping, knock it, knock. Okay, and then checking, and then reset. Okay, you can become a compass as well. Okay, inside I actually have a compass. Okay, but anyway, it's not the not the main things. Okay, the main thing is you can see this one. LED is blinking. Okay, the LED is blinking. This is the external LED. And you can see a smile face as well, because on start we have a show icon, which is a smile face. Okay, so if you do exactly the connection like this in the real world, they are the same thing. They will run exactly the same. So now LED is blinking in every 1 second. So how about you want to make it blink fast? So instead of blinking every 1 second, you can put like 0.5, also 0.5, change to 0.5 and start simulation again. It blink faster. Okay, it blink faster. This is how you connect the external actuator and let it blink. Okay, I think I need to jump a little bit already. Left 15 minutes. Okay. Okay, there's I have 6 guided activities. Activities 2, 3. Okay, activities 2 is the button. Okay, you can connect. Button is the internal button. Okay, I will explain it. You can try it later. I will go to the sensor part. Mainly it's the sensor part. So for this case is the button have A and B. Okay, so this is when you press the A button, it will turn on. If you release, it will turn off. Okay, this is a guided activity 2. Activity 3 is an external button. If you don't want to use this button, you can use the external button. So this is how it connect, and this is the code. So when you press the button, it will turn on the LED. If you release it, it will turn off the LED. This is how you connect the external button. Okay, external 4 is reading the sensor value. Okay, so again, internally, it already have a sensor value. Okay, how do you read it? The code is just simple like this. Show number, then this is the temperature sensor variable. So for this case, it will actually show the temperature value at this LED. Okay, you can try it later. So now let's go to sensor. I have 2 sensors only. Okay, just let you experience how do you connect a sensor. So for this, it's called PI sensor. It's a motion sensor. In other words, it's called motion sensor. It's called passive infrared. It's a motion sensor. Okay, motion sensor, you use a light to detect is someone blocking a light or not, something like that. Okay, by sensing the change of heat radiation. Okay, so when there's motion, it will output the high. If there's a motion, it will output the low. Okay, so let's try this one. Okay, let's try this one. So for this case, we will do a simple one. Okay, this one you're not yet done. It's okay. We do a simple one. Okay, so let's go back to Tinkercad. Okay, stop simulations. Okay, so for this case, you can just follow my instructions here. Okay, so now we're going to take the motion sensor. Okay, the component here use basic, then drag out the PIR sensor. This is a motion sensor, so you can put it on the left side. Okay, the motion sensor. Okay, so this motion sensor, it need 3 signal. Signal for it. Signal, this is one that will send back to the microbit. Power, of course, all sensor need power and also ground. Okay, power and ground, then you will have electricity. So for this case, we will connect the power first. Okay, power connect to the power. This is the power. Ground connect to the ground. Okay, so for this case, you want to be more colorful, you can use red color for positive. Okay, when you connect right, you can see that I can drag and connect like this. If you think that it's not that beauty, not that pretty, you can actually, when you connect right, you can see there's a mouse cursor like this, right? Okay, you can actually make a turn here. You can left click it, then it will make a turn. Left or right, anything you want. It will actually like make stop here and make a turn, so you can connect like this. On beauty if you want. Okay, so next is the ground. I connect a ground. Maybe like this, also can. Like this. Okay. So next is this one, we will connect to P2. This P2. Okay, P0 will connect to LED. We're not going to use it. We will connect to P2. Okay, we will connect to P2. So for this case, signal, you can use, I use purple. You can use any color you want. Just don't use red and black because this is for power. So for purple, this one will connect to P2. As simple as that. In the real world, it's also the same thing. Okay, they are also the same thing. Okay, so after that, go to code. Okay, go to the code. Okay, so previously this code is to bring the LED. We're not doing it now. You can take it out and delete. Okay, take it out, put in the center part, it will delete it. So now is for this sensor, it's a digital sensor. It's a digital sensor. Okay, when there's motion, it will sending a high, it will receive by the microcontroller. If there's no motion, it will receive a 0 from the microcontroller. So for this case, you just need to read this pin, whether it's high or low. Just need to read whether it's high or low. So you will, for this case, because there are two conditions, you will have if and else. Okay, you will have if and else. Okay, so for this case, if, put it here. Okay, sorry, not if else, it's if else. Okay, if else, put it here. Then the condition here, we need to go to maths, which is the green color here. And then we need to take the second one. Second one, you can see there's diamond shape. Okay, for this case, block programming also quite useful. I can see this is diamond shape. It only can fit diamond shape. Okay, it only can fit this diamond shape. Okay, so for this one, put it here. Okay, so for this case, we will read the digital pin. So go to input. Go to input and then digital pin. Lastly, digital pin. Okay, because it's input, digital pin, put here. Oh, sorry, sorry, no need to take this one, okay? Because this holding is a holding already. Just put it like this. Okay, sorry, so this one, just now I read this one, right? You just need to remove it. Just need to put the digital pin. Okay, digital pin P0 is high or low. Just put this holding inside. And then for this case, we can put a low here. Put a low, and then what you want to show at this microbit. Okay, there are a lot of ways to show in the microbit now. Okay, so for this case, you can put the output and show icons here. Again, maybe not show LED. Show LED. So if there's a motion, you can show like shape like this. Okay, so you can also, if there's no motions, if no motions, okay, you can show a cross like this. If there's no motion. Okay, so run. After you've done this, you can run. Okay, so there's no motion, so you put a cross. Then how do you simulate the motion? Okay, how do you simulate motion? So again, this is simulations. You can actually click on this PR sensor, and you can see. Let me do it again. Okay, there's a motion. Okay, you can click on this ball here, move around. Okay, move around. Oh, sorry. Why this it doesn't change? Because I'm referring P0. Okay, it's not P0, it's P2. Need to change to P2 because I'm connecting to P2. Okay, so run it. There's a motion. Okay, there's no motion. It's like this. There's motion. And it's a cross. Okay, this is how you simulate a motion. Okay, that's the motion sensor. Okay, I think we'll go to the last one. Okay, soil moisture sensor. I think it's more relevant to this hackathon, I think. Okay, so soil moisture sensor is the one that measure the water content in the soil. Okay, measure the water content in the soil. So it provides you information whether the soil is wet or not. Okay, it's wet or not. So for this case, what is the unit for the soil moisture is in percentage. If it's 0%, it's dry. If it's 100%, it's wet. Yeah, this is the unit in if we are using this soil moisture sensor. Okay, it's in percentage. Okay, this is a soil moisture sensor. So for this case, you can see that how to use this is actually these two plot is the one that have a sensor, have some chemical, not chemical, have some electronic kind of things to actually measure the water level, not water level, water moisture. Okay, it's just how to use it. You can see this. There's a probe here. You just need to slot it into the soil. That's it. This is how you use it. Okay, so for this case, how do you connect? It's also quite simple. Okay, we will connect to pin number 1. Okay, we are connecting to pin number 1. So for this moisture sensor, take note that there are a lot of different kind of moisture sensor. Okay, the pin in use maybe they are different as well. So you need to take note of that. Okay, you need to take note of that. Okay, so for this case is after you are connected, you can see there's a positive, red color is positive, black color is negative, and then there's a signal as well. This signal is connected to P1. So again, this is a moisture sensor. Okay, it will give you a range of moisture level. From 0% is dry and 100% is wet. So this is an analog sensor because it gives you a range of reading. It's an analog sensor. So for this case, we need to do something like this. Okay, set the moisture, read from the analog pin. Okay, we want to map the readings. 0 means it's dry. We want to make it map to 0%. If you read 813, which is a digital value, we want to map this into 100%. So this is called mapping. This is called mapping. Okay, so for this case, it will show the moisture. Show it where? Show it at the LED. Okay, the explanation like this. Let's do it now. Please still have time. Okay, so we're still using the same thing. Okay, so now is drag out the moisture sensor. Okay, drag out this moisture sensor. There's a question you can ask, what is the Tinkercad class code? There's no class code, okay? There's no class code. So because I didn't create a class, okay, what you can do, you can use your personal email. Don't join as students. If you join as students, you need the educator give you a class code. Okay, so don't go that way. Okay, use the personal email to create an account, then you can come to this. No need to join, you no need the class code to use Tinkercad if you use your personal email. Don't create using students. Okay. Okay, so back to this, we'll put it here. Okay, we put it here. Okay, so next thing is VCC. VCC is a positive, so we use red color. Okay, red color, put it here. Okay, right here. Okay, you connect this, make a turn like this. Okay, then I use black color for ground. Okay, make a turn like this. Okay, then the signal we connect to P1. Signals maybe is soil, right? I use brown color. This one connect to P1. Okay, then the code is here. Let's write the code. Okay, so for this case, the motions we can you want to remain or don't remain, it's okay. Now we remove it first. Okay, so now we're going to put the block exactly the same with the slide. Okay, let's do it now. Okay, so first of all, let's make it larger. Okay, so first of all, we need to have a variable. Right, not variable. Set moisture. Let's see, where is it? Oh, we need to create a variable for this case because it's purple color. Purple color is variable. Okay, create a variable called moisture. Okay, create a variable called moisture, and then you have this purple color come up. Okay, so for this case, we need to use the set moisture, put it here. Okay, to what? Okay, set moisture to what? So this moisture is actually read from the P2. Sorry, P1, read from the P1. So for this case is we need to have a maps here to convert the digital value to percentage. Okay, this is something like convert digital value to the percentage. So for this case, we read from the input, which is reading the analog pin. Again, I can see you can read digital pin and read analog pin. So how do you know which one you want to read? Because first of all, like I say, you must know what is the sensor type. This is the analog sensor, so you must read analog pin. Okay, click here, read from P1. So for this case, 0, this one changed to 1813. So to low, which is 0%, this is 100%. Okay, so of that, show it at the LCD. Show it at the LCD, show number here. So show the variable. Okay, sorry, I go a little bit fast, but anyway, it's recorded. It should be fine later. You want to refer. So after that, you can start it. Okay, start it. And then you can see this about 1.35. Okay, the moisture now is 1.35. So how do you increase it? You can click on the moisture sensor. You can see this is at the lowest dry. You can actually drag it in the middle. Okay, you can see there's a real new reading 46.86. Okay, this is how you drag the maximum. And you will see 99 point something. Okay, so this is example. How do you connect external sensor and actuator? Okay, external sensor and actuator. Okay, so actually after this guided activity 6, right, there's a mini challenge. I want you to connect a buzzer. Okay, connect a buzzer. Okay, there's some instruction here. You can try it later. Okay, if you have any question, you can always email me and ask me if you are not able to do it. So for this case, it's connect a buzzer. So this one, what it will do is, if your moisture value fall below 50%, okay, it will sound the buzzer. It will sound the buzzer. How do you sound a buzzer? This is the example code to sound a buzzer. Okay, if you're able to do it, feel free to share with me. Okay, if you're able to do it, okay, I will congratulate you. Okay, if you're able to do it. Okay, I think it's not that difficult. Okay, so left 1 minute. Okay, so for this case, let me just go to the rest of the slide. Okay, these are the other useful link. So just now, so you asked whether other than block programming, what are the things you can do? You can use Python. Again, you can use Python. You can use Scratch programming. Okay, you go to this website here. Okay, you can actually read it, the reference here. If you want to know more about the hardware, you can go to this link here. Okay, so you want to buy it, you want to purchase it. Okay, this is the Malaysian market, again, you can buy in Shopee or maybe Citron also can. Okay, so actually I want to promote computer engineering, but anyway, okay. So for this case, if you want just a little bit, okay, if you want to further study it, where can you start? If you want to study in degree, right? Okay, where can you start to learn this embedded system? So in Utah, we have this computer engineering course. Okay, and you can read it yourself. I just want to quickly go through. Okay, so computer engineering is a mixture integration of hardware and software. So for computer science, yes, they learn more about software. IT course, they learn more about software only. But for if you want to learn hardware and software together, if you like to convert code to circuits, then feel free to join computer engineering. If you want to know more about this. Okay, so these are the other informations why you want to learn it. Okay, and then these are the website you can learn it. It's in Kampa Campus. It's a 3 years program. Okay, so yeah, just a little bit of promotion. Okay, with that, that's all. Thank you. Back to Mr. Yo. Okay.
Thank you。好，谢谢我们的Dr. So 跟 Dr. Teo。OK，今天的 slide 呢，我们稍后会一样公布在我们的官网，然后跟今天的 recording 都会公布在官网啊。那如果同学有什么问题，都可以在 WhatsApp group 那边询问我们会有专门的人回答。OK，好，那就谢谢大家今天的出席。
谢谢 Mr. Yo。
OK，谢谢。
OK，谢谢大家。
OK，拜拜。
拜拜。
拜。